Good morning. I'm very happy and excited to the opportunity I have to introduce myself. I am Francesco GALLIANI, manager of the Research and Development Department of COMEC Innovative. Today, we will tell you about our experience and know-how relating to the Towpreg, talking to you about how this can be fundamental to making composite parts more economical and, above all, scalable in the different sector that I illustrated here. Speaking about COMEC Innovative, the company was founded in 1965 and has always been a family business, a distinct feature of the Italian industry. We have more than 50 years of experience in automation and machine assembly, and over 10 years in composite machine manufacturing. Our machines are completely designed and manufactured internally. We have certified procedure. We operate in a production area of 60,000 square meters. And in small pills, our number are 10 million of turnover and 65 workers. Well, now I'll tell you how Towpreg is a topic widely covered in my research and development department. In fact, I'll tell you 3 of our projects currently underway in which our focus is on technology for the efficient production and use of Towpreg. These 3 projects are called SMARTO Winding, Saphiro, and Cali V. So, let me to introduce this project. The first one, SMARTO Winding, is a project developed by 3 private Italian companies, the leading company COMEC Innovative, and the other 3 companies, Given, ATM, and Axist, and 2 Italian public engineer university from the Abruzzo and Marche region. The project focuses on the manufacturing processes of composite materials in the combination of tow carbon fiber and thermosetting epoxy resin system. More specifically, the project objective concerns the impregnation of tow, precisely Towpreg, and its subsequent use for the filament winding process in a new paradigm of quality and production efficiency. The project has 2 main objectives. The first allowed us to develop a new Towpreg technology currently being patented, with which we obtain this productivity and quality data. We have achieved efficiency and by creating a system that is quick to clean, therefore low maintenance and high efficiency. Increase the impregnation speed up to 120 meters per minute. Increase process accuracy in terms of resin content by weight by 1%. The second objective concerns the efficient use of Towpreg obtained. For this reason, we have designed and created a new era of filament winding process with up 6 axes capable of reaching high-speed process up to 300 linear per meter minutes. And only with Towpreg, it's possible to reach these speeds. Study and development of online technology control for the measurement of bandwidth during all process. In this project, as I said before, we have other partners. One of these is ATM Advanced Tool and Molds. that create a demonstrator of technology. The company is operating since 50s of last century in the field of manufacturing of tool, fixtures, and high-precision machine parts for aerospace, oil and gas, automation, and automotive market. ATM operating in the field of manufacturing of polymeric matrix composite materials. In the project, their focus are in a tow bar, so the use of carbon fiber in different areas offer the opportunity to save approximately 50% on the weight of the portable tow bar, which achieves lighter device that make possible a decrease in fuel consumption and total weight during the freight. ATM investigate and use the Towpreg technology for manufacturing a light portable tow bar for helicopters. This device allows entering aircraft for their initial perching spot to take off runway. Conventional tow bar consists of three main parts: a metallic cylindrical tube affected mainly by tensile force, a first end which serves as a union between the tow bar and the tractor vehicle, and a second end which connects the tow head and the shaft between wheels of the landing gears. The manufacturing of thick composite parts need to carefully investigate the process induced residual stresses, since they can contribute to decrease the actual strength of part. We did Smart Tow-In project, a numerical tool based on chemical and physical properties of the material have been developed, always through the use of Towpreg. Speaking about the Saphiro project, developed by COMEC Innovative, which is the lead partner, and another company, Axis, which deal with the processes quality control. The general aim of the project is to design and build a tank for the accumulation of hydrogen gas made of carbon fiber, more specifically a type 4, and more specifically, the tank we are building will be strict made with Towpreg. Now we are in the material qualification phase, and obviously the Towpreg that we are qualifying will be our product, made with our process developed in our laboratories. Subsequently, the wind process will always be done with our technologies. It should be noted that the aim of the project is not to develop a tank to bring it in the market. But in COMEC, we are convinced that to give our customers the best service, we must be the first to use our technology to also produce a challenging product. In order to always improve our technology, because we have stressed them before our customer do it. But this tank has a particularity. In fact, in the project aim requires is to be sensorized. We have chosen to use an additive manufacturing technologies called aerosol jet printing. We are the only private company in Italy to have adopted AGP. This technology is the only one able of placing printing sensor, directly on the shell of the tank. This sensor will be used to carry out continual structural monitoring through tank's life cycle. We then functionalize the surface instead of inserting other fiber inside of the composite structure. In the video, you can see the technology works. So, in the third and final project on which we are working, Cali V is the result of the collaboration between 4 private companies and the University of Naples. In this project, the challenge is to create a vertical takeoff aircraft that can represent one of the possible alternatives in the scenario of the mobility for the next future, for people and goods. There are many challenges in this project because we want this mobility to be accessible to many people and to have a low environmental impact. So one of the challenge is to reduce the weight of the aircraft and do it at a sustainable cost. For this reason, the need for a light fuselage made in carbon fiber. COMEC, in this project, introduced the use of Towpreg. We are therefore we are introducing an automatic lamination process to make the production of Cali V scalable. Our process must also be economically sustainable in terms of raw material. So we will use the Towpreg. Our solution will be called TFP, Towpreg Fiber Placement, a technology optimized for the use of Towpreg instead of little carbon fiber. So now I leave the stage to my colleague who will explain to you how the research and development technology become technology for the market. Thank you all.
Okay, so good morning. My name is Zhanyshbek. I'm a business development manager, and I worked for many years as a project manager of new generations of Towpreg and filament winding machines. My colleague Francesco has showed all the wonderful benefits of using Towpreg today, and as you've noticed, it has a capability of reshaping production processes in composite industry, especially and also in the pressure vessel manufacturing sector. Now let's talk about some insights regarding the Towpreg selection. So as it is not used commonly and everywhere, many startups, companies, and research and development centers, they struggle to find useful information today in the internet. I would like to talk about the very basics. Surely there are some key aspects in choosing Towpreg, such as the right application, the type of fiber you need, type of resin. You must know the resin content, the precision of the resin content for your application. Sometimes you may need a certain bandwidth with a certain tolerance. They can be Towpregs with plastic film and without plastic film. And it is quite important to know the storage requirements, especially when you need a lot of Towpreg and the shelf life. But let's dive in the practical side of choosing a right Towpreg just by taking a look at it. I'm sure walking through many booths here at JEC Worlds 2024, you have already seen plenty of Towpreg bobbins. So let's talk about the very simple practical tips that will help you to identify a good product. We will start from unwinding. So let's imagine you have a bobbin, you unwind the fiber, and you see how it unwinds. If it's sticking, then it's going to be difficult to unwind it easily. So we can just leave that bobbin there. If it's unwinding easily, then you can proceed to the next steps. So let's see now the repeatability of the material. Are there any knots or twists? Usually, to avoid a delamination, you will need to avoid the knots and twists, as they may lead to an accumulation of the air between the layers during the curing process, and you reduce the mechanical properties of the final composite part. Okay. So, next one. Okay, now how about the thickness repeatability? Often it is not required, but it's always good to have a look at the shape in the section. Because the better shape means the better deposition. Okay. It is the same for bandwidth. A good Towpreg will not have holes or fuzzy edges. This is especially important for avoiding gaps or overlaps and making the final composite part as similar as possible to a perfect simulated version of it. So let's imagine that we found a good Towpreg. The unwinding is okay, the thickness repeatability is fine, the bandwidth is fine. But the Towpreg is the combination of fiber and resin. Yeah. So if you take the fiber and you start to open it from the sides, you will see how it opens. And if it's opening evenly, like a spider net, like you can see on the slide on the right side, then the resin distribution is good. Okay. If it's sticking on one side, so it's dry, or it's too wet on the other side, then the distribution is not okay. And one more thing which is quite important, and you can notice it immediately, it's a bobbin shape. Okay. A good Towpreg producer will pay attention to each detail and is gonna make not only technically but also aesthetically a perfect product. A better shape means that you can keep more Towpreg on each carbon tube. Okay, we COMEC Innovative as a machinery producer have a long experience in Towpreg, and last year we patented a completely new system of impregnation to let our partners impregnate different types of fiber, like glass fiber, aramid, carbon fiber, and organic fibers, using not only epoxy but also other types of resin. These are two types of Towpreg machines we are supplying today around the world. Tow Uno, and Uno means one in Italian. It's because Tow Uno can process one bobbin at a time. And we have Tow Quattro machine. Quattro means four, because the machine can process 4 bobbins at a time. Okay. Let's see the main characteristics now in detail. Tow Uno is a laboratory equipment for research and development centers. It's designed to help to understand better the impregnation process, to develop and try different resin formulations, and find a target fiber and resin combinations. It produces a high-quality Towpreg and is user-friendly and very easy to handle and clean. We supplied a series Tow Uno machines to all the continents and see a trend that we predicted many years ago. Now, if you have some competence in this technology and you need to ramp up your production, we have a Tow Quattro machine. For companies that are committed to become a global leader in the Towpreg market, it has a patented impregnation technology and it produces up to 1,000 kilos of Towpreg a day. Tow Quattro needs only one operator and prepares and loads the resin mix automatically. It's easy to clean. It takes maximum 20 minutes to clean and reset the machine. It produces almost no resin waste and has the most accurate resin content you can find in the world today. And it has a quality control system. When we started this journey many years ago and our research and development department worked on a more sustainable and efficient way of producing pressure vessels and other composite parts, and we introduced our Towpreg machines, only few companies really understood our choice. But today, when there is always a bigger demand for hydrogen pressure vessels, investors start to realize that the bottleneck in the production of hydrogen pressure vessels is always impregnation. Here you can see our complete hydrogen pressure vessel production line that we designed together with Aumatec, another Italian company, our partner in line assembly and pressure vessel testing equipment. We are both located in the same geographical area. This is a line for the production of 30,000 pieces of 56-liter pressure vessels a year. It has liner assembly machine, curing and testing equipment, filament winding machines, and many Towpreg machines. Okay, because for a mass production of pressure vessels, using Towpreg not only means a more repeatable and reliable production, but better efficiency and sustainability. To give you a concrete example, if you're still not convinced that Towpreg is the future, for each 10 million euros of your investment, you can save 2 million euros with Towpreg. Okay? So thank you for your attention. Yeah, please visit our website, and you can also visit our booth here at Hall 5 and 10. Thank you very much. Have a nice show.